sodium is our 1s. Remember, we have everything that we had for neon, plus we're going to add one more electron. According to the periodic table, where is that electron going to go? What energy level, first off? Where is sodium's electrons in? What energy level now? 3. What type of an orbital? S. Every time we go to a new energy level, we start off with an S. That's what it tells you in the periodic table. So 3s is 1. So the electron configuration is 1s2, 2s2, 2p6, 3s1. Okay, in your periodic table, you shade it in. I'm talking about sodium. Sodium's in the S's. It's a 3s. And then magnesium would be the second element in the S's, in the 3s. S2, 2p6, 3s2. My S's are filled, so where do I go over to? Where does aluminum go over to? P. I'm still in the third energy level. What shape orbital am I in?
P.
P. That's why you have it shaded in your periodic table. From the S's, I can only get 2 electrons in an S, so now I've got to start filling the P's. So I'm going to go to aluminum. 1s, 2s, 2p, 3s. How many blanks for the 3p?
3.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons. Aluminum is element number 13. One S2, 2s2, 2p6, 3s2, 3p1. All right. Now's where I'm going to do the dot, dot, dot. Silicon would be 3p2. Phosphorus would be 3p3. Sulfur would be 3p5. Excuse me, 4. Chlorine would be 3p5. And argon would be 3p6.
Argon's an AR.
Oh yeah, thank you. That's silver.
Yeah.
Sure.
So, is there any time that you have to use the really long one with the arrows, or can you just use the electron configuration?
Usually. This just gives you a better idea of where the electrons are. So for instance, something that we're doing in AP Chem right now is we're looking at what shape molecules form, or what type of ions. It helps if you draw out the orbital notation.
Okay.
So would do you always have to do all of this? No.
Okay.
No. So 1s2, and there is a shorthand to writing all this also. That's what the noble gas notation is. Okay? So there's also a shorthand to this.
Okay.
Because by the time you get to an element like hafnium, okay? So by the time you get to hafnium, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, et cetera, and you're writing and writing and writing. Okay, so there's a shorthand to do that, and I will show you that. However, you can't know how to do the shorthand unless you know what the longhand is. 2p6, 3s2, 3p6. Again, we've got all our orbitals filled through 3p. We're at the end of the row.
Which one did I forget?
Thank you. Okay? Now, here is, in the fourth energy level, is where an exception occurs. Okay, so you should notice a discrepancy between what you wrote there and what your periodic table is telling you.
Yeah, shouldn't the third energy level continue for another level?
Pardon, Anna?
Oh, wait, never mind.
So what does that say is in the third energy level? A what? A d orbital. Well, what's your periodic table telling you that potassium, the next element, has? What type of energy level are we telling? An S, and then we're in what energy level? The fourth. Huh. There's where the exception lies. Okay? So let me show you first what potassium and calcium look like, and then we'll talk about what that exception is. The periodic table's right. You are going to an S energy level. Does everybody have this one? Okay, so there was argon. Okay, so now we're going to go to potassium. 1s, 2s, 2p, 3s, 3p, 4s. All right? Just fill all those electrons in order. That's Aufbau principle. They're always filled in order with one exception. Right, that was argon. This is potassium. Okay, so potassium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Calcium is next. Calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2.
Why did these skip D?
That's where the exception is. I didn't skip it. Nope, we're gonna go back to it right. Okay? You may draw the orbital notation in there or not. If you've got the feel of it, you don't have to draw in the orbital notation. I'm just gonna draw it in quickly. So I would like you to take your third colored pencil and shade in the middle of your periodic table. Don't worry about the 2 rows at the bottom. Shade it in the middle of your periodic table with another color and put a D above that. We're running, okay, so I'm gonna keep going here. This is where the exception lies. Scandium comes back now and fills the 3D sublevel. So why did we fill the 4S before the 3D? Because the 4S and the 3D are extremely close in energy. The farther we get away from the nucleus, the more overlap there are those orbitals. There isn't a whole lot of difference between the 4S and the 3D in terms of energy. So an electron, we have this nice spherical orbital. The d orbitals, like I had, many different kind of funky shapes. So it's actually easier for an electron to slip into that s orbital, expend just a little bit more energy, and go into an s orbital, rather than the 3D. Very close in energy. It's like, let's see, I go to and check into a hotel, I can get the room with the king size bed, or I can take the one with the twin bed. I gotta spend $3 more a night to get the one with the king size bed. I'm gonna take the king size bed. Yeah, I'm gonna take, so that's what electron does. A little bit more energy, I'm gonna go into the 4s. So every time you go to the Ds, which are the transition metals, they're always one behind what energy level you're in. So this is 4S, but these are the 3D. That's the exception you have to remember. When you start filling the Ds, they're just one energy level behind. So scandium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Okay, so somewhere on here, write exception. Fill 4S before 3D. We've got just a couple of minutes left in class. I don't expect you to walk out of here and when you come in next time to give me the electron configuration and orbital notation for yttrium. I don't expect you to be able to do that. You will get many more. Ben, you've already done this section. This cleared up any questions you might have had when you put the two things together. Okay, so now if you have any more questions, you're going to get a lot of this material again in 3D. One thing I want you to put in your periodic table, and I'm not going to test you or hold you responsible for these. I might have put one on a test or a quiz just for fun. It's never like a level 4 breaker. These are the F's. And the F's are actually 2 rows behind. So if this is 6S, these are 4F. And these are the 5D. Okay, and we can talk about that when you get to that section, but those are the F's. And I didn't even have you chain those in because I'm not going to hold you responsible for those. Okay, so when you get to that section, you have notes to refer back to. Hopefully when you put both things together, it'll be a lot more clear. Okay? And again, of course, if you have questions on this stuff, ask me when you get there.